Okay, so with respect to the performance tuning, so as much as possible, we should try to design our mapping with minimum transformations. So with lesser number of transformations, we'll have to build our mapping, because the moment when we are increasing the number of transformations, so then the load on the mapping will be get increased. For example, in a place where we are using uh, two filters, two filter transformations. So instead of having two filters, we can go with a router. Okay, and so if at all we wanted to combine two multiple source systems, not source system, multiple source tables. Okay, so if at all we are using a union transformation, so if all the tables are in the same schema, we can go with the source query. In the SQL query itself, we can do a union and we can get the data, so that we can limit the number of transformations. Okay, if at all we are using lookup on top of a table, and the table which is being used in the lookup and the table, the source table are in the same schema, so better we can go with the join. We can go with the join. So join in the join in the source, we can do it in the source query itself. We can do a join. We can get the data, so that we can limit the number of transformations. So which is going to improve the performance. Okay, and also when we execute, so and also we need to filter out the data as much as possible from the source query itself. Okay, so when we are getting the data, if at all we are using any kind of a filter transformation in middle to filter out the data for a certain condition. Okay, so we need to check that is there any possibility to filter out this data in the source itself. Okay, so what is the point to get the data to the next transformations and filter the data. So as much as possible, we will have to filter the unwanted data in the source query itself. Okay, then if the mapping is taking time or the mapping task is taking time, then we need to see the mapping task statistics. Okay, let me open IICS. Oh my God. That's fine. Okay, so you can just open the session when the mapping task is running, right? If you click on the mapping task, you can see the running stats, like how the data is getting processed. Okay, so like the data is the reading from the source and loading the data into target, how it is happening, whether it is happening in thousands or hundreds. Okay, for every second we can see the differences, the data transformation differences that we can see. So those differences we need to see if at all the data difference within the seconds are different, I mean very less. Okay, then we need to open the session log. We need to download the session log. So when you download the session log, it will come like this, right? This is one of the, this is a parameter file. We did downloaded some session logs, no? Yeah, so this is the session log. And when you go to the session log, so somewhere you can see the source query issued to the database. Okay, so when the source query is issued, you can see the timings here. So when the source query issued to the database and when the first row written from the database, you can get that information from the session log. Okay, now if the source query is taking more time, then we need to do the tuning. We need to do the query tuning. We have to tune source query, and then we will have to keep the query which is running very fast. Okay, so that we will get to know. So because in the session log for every activity, okay, we will see the timings. So when this particular step is happened, let's say if you see here, right, so this particular step is started at this time and this particular step is finished at this time. So like this, so when you have the query also in the session log, you can get, so query issued to the database, at what time the query is issued and what time the first row written from the database, how much time it is taking, to issue the query and to get the first row. So by seeing the time differences, we will get to know how much time it is taking. Okay, so and then once we do that, once we do the source query tuning, then the mapping performance will be better. Okay, if still it is taking, let's say it was taking around half 1 hour time, now it came down to half an hour. Okay, because the source query part is fixed. Okay, so there are several places of the mapping that we will have to fix it. So that is first step is query, and the second step is if at all we are using any joiner transformation. If at all we are using any joiner transformation, so in the joiner transformation, so which is master, which is detail, we need to see. So always lesser number data should be master and more number of data should be detail. More number data should be detail. So have we verified that properly? Okay. So if the joiner is taking time to prepare the cache, okay, then we have an option of sorted input. So when we enable sorted input option, and if we get the data in sorting order, the performance of joiner transformation will be get improved. Okay, and if at all we have a lookup transformation, and the lookup transformation is having cache, it is going to build cache, but the source query, the lookup query is having is giving very less data. Lookup query is giving very less data. So, but the actual table is having huge volume of data, like millions of data is there. But we have a requirement that we have added a query in the lookup. So when we have added a query in the lookup, okay. So if the query is taking less time, sorry, lesser data, and from source also we have very less data. Like we are using an incremental load where we are getting some 100 records or 50 records or 80 records. Okay, so if the source volume is very less is coming up, but still lookup is taking more time, so then instead of going for a cached lookup, we can go for an uncached lookup. Okay, because if you open the lookup properties, so there is an option of cache enabled. Okay, so if you cache enabled, by default it will be checked. There will be a checkbox, it will be checked. If we disable that, if you remove the checkbox, so then lookup won't build cache. So for every record, the query will execute on top of a database and will get us the data based on a condition. Okay, so that since we are getting lesser number of data from source, we don't need to build any cache. So with the uncached lookup itself, we can go to the so with the uncached lookup also we can complete the mapping. Okay, because the source is having lesser number of data. So like this for every transformation. Okay, so if at all we are using an aggregator transformation, so in the aggregator transformation where we will be having sorted input option. So when we enable sorted input option, this aggregator transformation also is going to build cache. So when it is going to build cache, for why it is going to build cache, because aggregator will be having group by port, so it is going to form different groups, right? So when it is going to form different groups, for every record it is going to search, do I need to create a new group, or is there any group already exist? Like that it is going to check. So just to avoid that, we can enable sorted input option, and we can get the data in sorting order, so that it is going to form 1 to 10 one group, 10 to 20 one group, 10 to 20 31 group. It will not look for this particular record is having a match in the any other groups or not going to look for that. It will automatically create groups as we have enabled sorted input option, and we are getting the data in sorting order. Okay, so like that we are going to improve the performance of a mapping with respect to the transformation. So these transformations, each transformation will be having certain techniques. So majorly the mapping performance causes by the transformations which are building cache, like joiner, aggregator, lookup. So these are the transformations usually consume more time. Okay, now once the transformations are also perfect, fine, and then we are going to have partitions. Okay, and then we are going to have partitions of the source. So if source is a flat file, we can create 10 partitions or 20 partitions or 30 partitions. Okay, but we need to make sure when we are creating partitions, the load on the mapping, like when we say 10 partitions that we created, so the data process will be improved by 10 times. Data processing will be improved by 10 times, because So by default, there will be one reader and one writer and one transformation threads will be created. So when we create partitions of 10, so then 10 readers, 10 writers, and 10 transformation threads will be get created. Okay. So with the after the performance of after the improving other transformation other transformation other transformations, and if you create partitions, so then let's say after improving transformation techniques, so then it is taking some 20 minutes. Now when we created 10 partitions, it will come down to 2 minutes, because 10 times it is going to be faster. Okay, so recently in one of my project where I have faced the same kind of an issue. Okay, so the source is having huge volume of data, very huge. Source is a flat file, and very huge volume of data is there. Okay, when I do update insert, okay, from to get the data from source itself, it is taking more time to get the data from source. It will. So we were about to complete our UAT, and then we were about to go to production, but in the UAT we thought of executing one set of file end to end. So it is running from 17 hours, 18 hours, still it did not completed. Okay, so that time we got a huge issue in the jobs, because now IICS won't execute that many hours in production. Okay, so in UAT also there are few jobs they got failed because of overload on the mappings. Okay, that time what we did was we created one temp table. Okay, from source to a temp table that we loaded. So that temp table will be a truncate load table. So then we have added number of partitions in the mapping. We created partitions like 20, 30, 15, 10. According to the data volume, we have created the partitions, and then we'll first load the data into the temp tables. Okay, first we load the data into all the temp tables by creating partitions. So that it was taking the mappings which are taking some 10 hours or 15 hours time, it came down to 2 hours or 3 hours. Okay, now 1 or 2 hours that came down. When it came down to 1 or 2 hours, okay, then it was easy for us to use that temp table as source and load the data into the target table. So since the temp table and the main actual table is there in the same database and same schema, okay, we have created in the same schema. What we did was we did a join in the source qualifier. Okay, we did a join in the source qualifier to eliminate the same rows which does not needed any change or which does not needed any check. Okay, we did the join in the source query itself, and then we started loading the data into the target table. Then it was very quick. So now within 1 or 2 hours, the entire load is getting completed. So that's where the partitions are going to help us. So with respect to IICS, so the performance will be the volume. If the volume is getting increased, obviously the performance hitbacks will be there. Okay, we should be very much careful about the performance of the mappings of IICS. And also we have one more push down optimization. So this is the last option. So this push down optimization is of 3 types: source push down optimization, target push down optimization, and full push down optimization. Okay, if source push down optimization meaning starting from source, as many number of transformations as possible, it is going to build a single query. The integration service is going to build single query, and then that query issued to the database, and whatever the result is coming from the database, so that it is not going to process through the transformations, because all the transformation logics are already implemented in the query. Right, as much as possible from source, it is going to build a query, issue to the database, and get the data, and then it will start processing through the next transformations. Okay, and target push on optimization is basically from target till the before transformations, as much as possible, it is going to build a query. It's going to build a insert query with select statement, and it is going to implement all the logics of that transformations, and then it is going to hit the database, so that it is going to stop, or it's not going to use the transformations. It will try to implement that logic in the query, and that will be issued to the database provided. So when we are using this push down optimization, so the tables that are being used, so those should be in the same database and same schema. If they are the different databases, it will be very difficult for them to connect to the different databases and get the data. Also full push-down optimization. So it is going to build the queries as much as possible from source and as much as possible from the target. So majorly, this push-down optimization is going to build the SQL queries and issue to the databases. It will try to limit the usage of transformations in the mappings, so that we can it is going to improve the performance. So these are all performance tuning techniques that we are going to use it in real time. Okay. So if somebody is going to ask you what is the complex situation, complex mapping that you have ever heard, so then you tell about the one which I explained with the partitions. So this was a very critical situation that we got. So for that critical situation, so this is how we implemented the mappings. Okay. So please listen this recording, prepare your notes. Okay. If at all you have any questions, let me know. So any questions?